Hey, welcome everybody. So in this video, I want to give a quick overview of Python Lab 3. So I am working with the Google Colab document, Python Lab 3. I've got Google Colab open. So the first step would be to view this document, save a local copy into your own Google Drive. So I'm assuming you've done that, and now you're able to edit this file. So that's basically the instructions down below here. So in order to begin this assignment, you're going to have to run this very first block of code that's going to create the elephant and load a couple of libraries that we're going to need in this assignment. So if you don't run this first block of code, you're going to get errors in trying to execute future blocks of code. So there's nothing you need to do in this code cell at all. Notice it's importing a couple of libraries. The NumPy you should be familiar with. There are a couple of others. So when you run this code, it's going to import those libraries, and down below it created our elephant, the blue elephant over here. So we're going to need this elephant in the future problems. And so let me also say that each time you walk away from working on this assignment, if it's in a web browser, and let's say you walk away for an hour, your session is going to terminate. And when you come back and begin working on your Google Colab assignment again, you're going to have to kind of restart your session. And that means you're going to have to reload these libraries and print the elephant again. So each time you open this document after being away from it for a while, just make sure you run this first line of code. It doesn't take very long, so that you've loaded your libraries and have your elephant. So question one is asking us to consider the following transformation. We're going to reflect this elephant over the X1 axis. So let me draw a little graph over here, and I really hope this shows up when you're watching this video. So I've got a little graph in red, and we've got the X1 axis, the horizontal axis, and the X2 axis over here. And so for example, a reflection over the X2 axis would take a point such as this one, and now it's going to reflect it down over here. So we can represent this transformation with a matrix. And one way to do that is to consider where a couple of key points go. So for example, here is the vector 1, 0, the first standard column vector. And you might want to think about, under this transformation, where's this vector going to get mapped to? And in addition, the other standard column vectors over here, this would be the vector 0, 1. And where does this get reflected to after this transformation? So after you identify where these two column vectors go, then you would enter the corresponding entries into the matrix that would represent this transformation. And remember, when you want to edit these cells, you can just double click on them and then enter your values here. So maybe I think this goes to 4. And this goes to 5, and this goes to 6, and this goes to 7. These are not the correct answers. But you can see they now get filled into my vectors, and you'd want to do the same with matrix A over here. So question one is just asking you to enter some values in place of the question marks. And let me clear my drawings. Okay. Question two is going to actually execute this transformation. So all you need to do on this problem is enter the values that you just entered in question one down in this line of code over here. And there's a warning here again to remind you that you need to run that first code cell to get the elephant and those packages loaded. As long as you've done that, after you enter your values over here, it's going to plot them. So let me just input a couple of random things. So let's say mine was 1. And now when I enter these values, be sure you're entering them as decimals. So if I have a 0, I would enter 0.0. And maybe this is a -4. This is not the correct answer. But I would enter my values in over there. And then there is nothing else that I would need to change. So don't edit any of the rest of the code, just enter your matrix and hit play. And then down below, it should generate the original elephant that we created in the first cell block and your new transformed elephant. And again, I did not enter the right values, so that's why I'm not seeing the right image over here. And so if you mess up and you're not seeing the elephant that you meant to see, that means you probably made a mistake in question 1. And this is the beauty of these worksheets, is that you can check your work along the way, and you might just need to tweak your work. Question 3 is dealing with a horizontal contraction. And so in this problem, you're given where the standard column vectors get mapped to. So this is all the information you should need in order to fill in the values in question for matrix A. So again, you would just need to double click on this text box, enter in your values in place of the question marks, and that's it. And then question 4, again, you want to make sure that you've run the elephant, that first cell, code cell, before running this one, but we've run it and I'm still continually working in my document. So I don't need to go back and run it again. All I need to do here is enter in the corresponding values for matrix A again, and then hit the play button and then check my work. I should see output of the graph of the original blue elephant and my new red elephant. Question 5 is asking us about a new sort of transformation that I didn't talk about in the videos, at least, which is a rotation counterclockwise. So now we're in the plane, the x1, x2 plane, and I've got some point, let's say it's over here. So this transformation is going to rotate it counterclockwise by 90 degrees. So it's going to rotate it. That's my attempt at drawing a 90-degree angle down over here. Okay, so the important thing, it's a counterclockwise rotation, so we're rotating this way. So for example, what we're told is this vector 1, 1, which is over here, right? Under this rotation of 90 degrees, it gets mapped over here to the vector that minus 1, 1. So that's what this information is saying. You could similarly make sure you understand how this map is going by verifying that this vector minus 1, minus 1 gets mapped to 1, minus 1. But in order to construct the matrix to represent this, we are going to need to identify where the standard column vectors go. And so that's what you're asked to do in parts A and B. Under this rotation counterclockwise by 90 degrees, where do standard column vector 1, 0 go and 0, 1? Based on that information, you should be able to complete this matrix A. Again, double clicking on this and filling in the double question marks in the LaTeX. Okay, and then question 6 is asking you to enter those values into the matrix. Again, making sure that you've first run and created the elephant and loaded those libraries, and that when you enter these values, you're entering them using decimals. And then don't edit the rest of this stuff. All you need to do is input matrix A, run the code, check your work. Then finally, the last 2 questions are asking you to create your own sort of rotation. And so in general, we can create a matrix to represent a rotation counterclockwise by theta radians using the matrix, I'll call it a rotation matrix over here. So for example, if you wanted to rotate points in the plane, were to rotate things by 60 degrees, pi over 3, we could plug in pi over 3 in place of theta, and this would be the matrix to represent that transformation. So what I would like you to do in this problem is consider, well, how are we going to need to rotate this elephant so that its eyeball winds up in quadrant 3? So the quadrant 3, if you recall, is down over here. This is quadrant 3 in the plane. And initially, the elephant, its eye starts off over here. And we want to think about, well, how much would I need to rotate the entire elephant so that after this transformation, the eyeball winds up over here? So maybe we can try. So there's really just two things you need to change in both of these questions. Is you need to pick an angle over here. So enter in some LaTeX code and then check your answer in the next code cell. So let me say, for example, I am going to try an angle of 2 pi over 3, right? So that would be 120-degree angle rotation. So here's where it's telling me to do something. What I need to do is just enter something in the very end over here. So all I would do would be enter 2, 3, and maybe this is my guess at what might work. So I'm going to guess 2/3 pi. So I just need to replace 2 question marks in this problem. And then when it comes to question 8, all I need to do is enter that angle in this place of the code, and that's it. Okay, and then the matrix A is going to be created with this block of code, so you don't need to edit that matrix at all. And then the elephant's going to be rotated with the rest of the code. So the only thing you would need to do is enter here 2 pi over 3. So I'm going to enter 2 times pi, and the way that we get pi is we need that math package. So I'm going to type math.pi. This means go into the math library and use the value for pi, which is stored in that library. And then I'm going to divide by 3. So you need to enter your angle in radians, first of all, and a way like this would work. And it's really important in Python that you specify all of your operations. So sometimes when we multiply things, we might just write 2 and the pi next to each other, and we know it's 2 times pi. Python doesn't know that. So if it sees a 2 next to a pi, you need to tell it to multiply the 2 numbers by putting that asterisk in between. So maybe I think an angle of 2 pi over 3 is going to work. So all I need to do is enter my answer here, hit play, and then I can check my work. And here you can see the eyeball did not quite reach quadrant 3 over here. So we need to rotate it a little bit more, and that's kind of your task, is to figure out what is an appropriate angle of rotation. There's going to be a range of values that would work that will get the eyeball over here in quadrant 3. So if you made a mistake like I did, this just means I need to go back to question 7, try a different angle over here, make sure I change my answer over here, and then try it out in question 8. Okay, so if you have any questions on the assignment, just feel free to reach out and let me know.